This will help you out for the quiz tomorrow, so I'm not hitting the quadratic regression sheet yet. The first one is, we want to warm up. We have 2 plus 3i and 4 minus 3i. All right. In this case, I is not a variable. It is. Yep. So I is equal to the square root of -1. I squared is -1. I to the third is equal to -i, and I to the fourth is equal to 1, and then it repeats. So if I want to know it like I to the 30s, let's go I to the 35th. 4, the reason it repeats every 4, or it repeats every 4, so I'm going to go 435 goes 8 times, because that gives you 32, leaving you I to the third, and I to the third is equal to -i. Okay, so that's basically how you would run through that problem. I think on the quiz, we're only going to look for if you have I squared, you substitute -1 in. So let's FOIL this problem together. It looks like a variable that we're working with. So I'm going to get 8 minus 6i plus 12i minus 9i squared. 8 plus 6i plus 9. Combine those like terms. So we get that. The reason, why did this change to positive 9? I squared equals -1, so it becomes -9 times -1, which is positive 9. Okay, the next question is, looks like I'm subtracting the 2i values. Somebody tell me what that says.
7 plus 2i.
Thank you.
Minus 4 plus 3i.
-4 plus 3i. Okay. So I need to distribute this negative over here and here. So I get 7 plus 2i minus 4 minus 3i. Yep. So that's 3 minus I. Problem's done. And then I have 5 over 2 minus 3i. 2 minus 3i. Remember, for some reason I had a meeting a long time ago that said, hey, don't have I on the denominator, so I have to multiply the top and bottom by the exact same thing. What am I going to multiply top and bottom by? 2 plus 3i. So that's called the conjugate. Being you're multiplying by the same on top and bottom, it still is the same size fraction. Distribute on the top, so that goes here and here. That gives me 10 plus 15i. On bottom, I'm going to get 4 minus 6i plus 6i minus 9i squared. Top staying as is for right now. Those cancel each other out. What's negative 9i squared? 9, so 4 plus 9 is 13. That problem's done. So those are definitely types of problems you will see. Exact answers. So complete the square or quadratic. Again, guys and girls, I truly feel that the completing the square is going to be the better method for you to use. It's the better one to stick with because quadratic, you're going to make the sign errors. Being that I have an A value of 2, a B value of 8, and a C value of -3, we're going to have way too many negatives in that quadratic formula, and you're going to forget one, and you're going to get a goof up on the problem. So I truly feel if you complete the square, it's going to be better for you. So I got 2x squared plus 8x. Is that -3? All right. So let's complete the square. Let's complete the square to solve it. First thing I need to do is do what? Do what? Yeah, I'm going to divide everything by 2. I want that lead coefficient to be 1. So that's going to be 0 equals x squared plus 4x. And I'm going to make a space and keep this as a fraction. Is that okay so far? Does that make sense? So I want to complete the square. And completing the square, I have to take care of this. But remember, I have to have an opposite value outside here as well. Okay, so what is half of 4? 2 squared is 4. So I'm going to add 4, and then I'm also going to subtract 4 from the same side. Is that okay? Notice I stayed on the right side of the equal sign to take care of that. This is now a perfect square trinomial, which is x plus 2 and x plus 2, or the same thing as x plus 2 quantity squared. I'm going to combine negative 3 over 2 minus 4 over 1. Okay, let's make it legal. Let's make that 8 over 2. That's negative 11 over 2. Is that okay? Now I want to solve it. Okay, remember this is vertex form. If it's y equals, you'd have a vertex of negative 2, negative 11 halves. But we're solving it, so now I'm going to bring the 11 halves over here by adding it. Take the square root. Don't forget the plus or minus. So I'm going to get plus or minus 11 over 2 x plus 2 equals that. So I'm going to subtract that. This is an exact answer. I'm not too worried about rationalizing the denominator, though. One thing that you will see tomorrow, and I know you saw it in Algebra 1 and possibly even Algebra 2, is the discriminant. And the discriminant deals with the quadratic formula. So if you add this, this is the discriminant right here. So if b squared minus 4ac is a positive number, that stands for number, not hashtag in this case, that means we have two real solutions, which means it crosses the x-axis twice. Okay? So if b squared minus 4ac is a positive number, so anything bigger than 0, then you have two real solutions, so it crosses the x-axis twice. If b squared minus 4ac is 0, you have one real solution. That means the vertex is on the x-axis. Okay? And then the last scenario that you might have is b squared minus 4ac is a negative number. You have known as two complex solutions. Means they're imaginary numbers. It won't cross the x-axis. Okay? So that means it would be a parabola either above it, the vertex won't cross it, or below it. Okay? And then the last thing, the axis of symmetry. So let's say we worked out a problem. We found we had a vertex of 5, 3 on some parabola. 1, 2, 3, 4, 5. 1, 2, 3. Okay? I'm not worried about how it's growing, whether it's going up or down or anything like that. The axis of symmetry is this line that is just a vertical line, goes straight down through the vertex. So if you did that, that would be x equals 5 is known as my axis of symmetry. Okay, so that's all it does, and let's just pretend I can make my count out correctly. Okay, so the axis of symmetry is very simple. Once you find the vertex, it's just x equals the x portion. It's a vertical line. Remember, vertical lines are always x equals. Is that okay? All right, let me run through the quadratic regression worksheet. Make sure we're okay with that. If you have your calculator, it'd be good to get out. Now I gotta sit down because I can't. Not that fancy with the calculator here. All right. God bless you. Fine. It would have been the same thing as the square answer. You probably just didn't use it. All right. So I would like you use the quadratic regression. So, I'm going to go under Stat. I'm going to go under Stat Edit. And I'm going to plug some values in for list 1 and list 2. Remember, you had stuff up in there. Go up to the top. Hit clear and then down arrow. And then if there's anything in list 2, again, go up to the top. Hit clear and then down arrow. And let's plug in our values. It says, the individual retirement fund, the following table gives the average amount of thousands of dollars in the individual retirement fund. Use the information to construct a quadratic regression to represent the model. Rounding all constraints to 3 decimals. For 1985, we want to use 1, and so on and so forth. X equals 2 is 1986. So it looks like I'm going to go, B in 1985 is 1. 1990 would be 5. 1995 would be 10. 2000 would be 15. 2005 would be 20. Are you okay with me going to 1, 5, 10, 15, 20? They just wanted us to start. 1985 is 1. And then the value, so 9,000, 19,000, 45,000. Okay. So these are 1,000. So I have 9,000, 19,000, 45,000, 101,000, 196,000. Okay. Make sure if you go y equals, if there's nothing there, things that you might want to remember to do is turn your stat plot on. So second y equals.
So did you do 1 through 10?
Do what?
What did you do for the list 1?
I did 1, 5, 10, 15, 20. I counted by 5s.
For list 2, you did the other one.
List 2, I just did the actual values.
But as 1,000.
Yeah, but I left them as 9 to know it'll be thousands. I could have had 9,000, 19,000, 45,000. It still would have been the same. Okay, so I'm going to turn my plot on. Hit enter. I like that. I want list 1, list 2. Some of you might look a little different. Once it's on, hit zoom and then stat. So zoom 0, is it? Zoom status? Or zoom 9? Zoom stat looks like 9. So this is going to give us a portion of our graph. It looks somewhat linear in this case, but it also looks like it's curving up a little bit. So let's pick the quadratic regression. So let's figure out the equation. So I'm going to go stat, calculate the quadratic regression, which is number 5. It's good practice that you put list 2 or list 1 comma list 2. Hit enter. Notice this only gives you your r squared value. R squared wants to be really close to 1, so we have 0.998. That's pretty close to 1. You got a 99.8% on a test, you'd be like, dude, I'm set. Okay, so that looks pretty good. This is the equation. My A value is 0.589. My B value is negative 2.76. My C value is 13.66. Okay, if I plugged it in, that would be standard form. So if I wanted to graph this, I can go y equals, where's it at? Bars. Then what? Statistics. Then what? Equation. And then what? Number 1. So plot it there. Once it plots there, you can hit graph. Uh-oh. God bless you. Bars, statistics, equation.
Yeah, that's what's happening in the last round.
Yeah. I'm doing wrong here. Real satisfied with this calculus there.
It's because it's saying x squared for x to the power of.
Second quit. Stat. Calculate. Quadratic. Quit. So So y equals roughly 0.58. Someone write this equation down. A is 0.589. B is 2.76. Negative 2.76. C is 13.67. You have that? We good?
Which one is this? What's the last one you need?
13.67. You got it? Alright, let me graph it. Let me clear this. I don't know, my calculator's getting goofy for some reason. What was my A value? 0.58? 0.589? Okay, x squared. And then B is 2.76? Is that what you said? And then, oops, I forgot my x. There we go. Alright. So, to the nearest $1,000, what will the fund be in 2010? So, B in 2010 is outside my data. What should I do in order to make it work on my calculator? I need to open it up. I need to zoom out a little bit.
How did you get the line? Mine's still the same.
I plugged it in manually. I'll take a look in a second. So, to the nearest $1,000, what will be worth in 2010? 2010 will be when we plug 1, 5, 10, 25. So, I'm going to calculate a value at 25. So, at 2010, this fund is worth $312,000. Okay. That's just basically how you'd go through each and any one of these. Let me ask you this. Could you tell by my graph, could you figure out when the fund would have, I don't know, say 225,000 in it? And if so, how would I do it? Well, I want to know what year would have 225,000 in our account. What would I do? Hint, I need a second graph. How do I make a second graph of that? Y equals, and B and everything was already in thousands. So I want to know when I'm at 225,000. If I graph it, it has two different intersection points. It has an intersection point here as well as here. I'm interested in this intersection right here. So I can go second, calculate an intersection, which is 5 in this case. I'm going to make sure my cursor is as close to that intersection as possible before I start hitting enter. Yeah, Y2. Y2 is 225. So enter, enter, enter. So 21 years after we start the account, we're going to be at 225,000. So that would be what, 2006? About halfway through 2006. All right? All right, put those away. I wanted to run through any questions you might have had on the homework from last time, which was the review. And the review, I believe, was on page 248. Is that right? Questions from review? Yeah. 70. Okay, problem 70 from the review. Dimensions of a box. An open box is made from a 10 centimeter by 20 centimeter piece of aluminum by cutting a square in each corner, folding up the edges. The area of the resulting base is 90 square centimeters. What is the length of the sides? Okay. So this is the box problem, a little different technique to it. So this is 20 by 10. Those are both in centimeters. Okay. So I want to cut out that corner. So I'm going to cut out the corner in each. So these are going to be where it's folded up, right? So now we know that the area of this region right here, this area of this region right here, at the base of this, once we fold up the sides, is going to be 90. So that means that the area was a length times a width. We know we cut up the sides because the original base, when I didn't cut it, is going to be 200 square centimeters, right? So now we have to figure out how we can get it to 90. Okay, I'm going to call this x, obviously this x, and this x, as far as dimensions go. So this dimension here, this distance right here is going to be how much? 20 minus 2x, good. And what's this dimension going to be right here? 10 minus 2x, good. So now that's the new length and width. That new length and width will have an area of 90 square centimeters. So I have length and width, so I have area is 90 equals 20 minus 2x and 10 minus 2x. If I go and FOIL this out, 40x minus 20x plus 4x squared. I can't read my own writing. Is that 20x? So 90 equals 200 minus 60x plus 4x squared. That's going to give me 4x squared minus 60x. Move the 90 over by subtracting it, minus 110. Let's see. 2 will go into everything. I don't know if it's going to factor or not, is it? So I'd say once you factor that, or if it can be factored, great. If you can complete the square, great. Or use the quadratic formula, great. You're going to get a negative answer, which you have to ignore. And the positive answer is going to be the result. Is that okay? Other questions from the review? Okay. Sure? No fibbing? Can I move to the lesson I want to do today? This lesson will not be on the quiz tomorrow. The quiz was supposed to be today, but I moved it to tomorrow. Is that okay? Ready for the lesson? Can we do the lesson? It's fun. No, you'll be fine. All right. Poke your neighbor in the eye if you need me to. If you need to get through this. All right. Graphing circles. So these are two circle equations. Okay, if they're set up and they're grouped, that should be squared, sorry. They're set up and grouped. In order to find the center of the circle, center of the circle will be opposite inside. Opposite inside. That's the center of my circle. Which means if I were to graph this at -2, 3 is the center of my circle. Take the square root of this portion, and it'll be your radius. So the square root of 25 is 5. Okay? Sometimes that might say it's 5 squared, and what's the square root of 5 squared? It's 5 as well. Okay, so if the radius is 5, that means from here I'm going to go 5 in all directions. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our circle is going to, kind of went out of the screen a little bit, but there's our circle. And I'll show you a little bit better how to graph that in a second. If I wanted to find the center of this, x squared stands alone. So where is the x component of the circle? 0. Okay, so there's nothing with it. So my center of this circle is going to be 0, comma what? -2. What's my radius? 6. Good. So if I wanted to graph this, 0, -2. That's my center. And from there, I'm going to go right, left, up, down, 6 in all directions. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's just pretend I can draw a good circle. Okay? So that's the first part of it. Ready for the second part? And you had asked about completing the square, so I'm going to do it on steroids now. Okay. Ready? So let's say I had a problem that looked like this. Okay, if I wanted to graph this circle, I have x squared plus 10x minus 2, y squared minus 8x minus 5. First move is I'm going to move the constant over to the other side. So that's going to leave me x squared plus 10x plus y squared minus 8x equals 7. Is that okay so far? You with me? Okay, so keeping your x and your y's paired together, you're going to napping again, or you're praying? Okay, good answer. All right, so with that, I'm going to keep my spaces. I'm going to actually move this over a little bit. Make sure I have a space here. And I now need to complete the square to fill this space and complete the square to fill this space.
Wait, why are you giving
So that was right here. Oh, that should have been a y. Thank you. I miswrote the problem. I apologize. Okay, so that should have been a y the whole time. All right, half of 10. 5 squared. 25. If I add 25 here, I'm going to add 25 over here. Is that okay so far? Half of -8. -4. -4 times -4. Positive 16. Is that okay so far? So this portion here is a complete square. What times what gives me x squared plus 10x plus 25? X plus 5 and x plus 5, which is the same thing as what? X plus 5 quantity squared. Plus, what is this? What times what gives me y squared minus 8y? Y minus 4 and y minus 4, which is y minus 4 quantity squared. Okay? Do the math here. 7 plus 5 is 12, plus 6 is 18. Carry the 1, 2, 7, 78. So the center of this circle. Wow, what did I do? Oh man, I tell you what.
I knew I shouldn't go to those new teacher things. 48. So the center of my circle is what? -5, +4. What is my radius? Square root of 48. Done. How big is the square root of 48? Well, square root of 49 is 7, so your radius is just a little bit less than 7. Should I do another one, or are you okay? Do I back down?
What?
You're good? Like, just make him stop. All right. So, quiz tomorrow. Okay. This assignment will technically be due on Thursday. We won't go over it tomorrow. Is that okay? So you have 2 nights to do this. Is that okay? So if you're like, dude, I just totally want to study, then tomorrow night after the quiz, then do this assignment. Sound good?
So completing the square is not on the quiz tomorrow?
Well, you might have some completing the square, but not circles. Is that okay? So this will be due. This will be due Thursday. What do I do? Give you guys a couple minutes to start, stretch, poke someone in the